This is a short screencast to try to illustrate recursion on a simple example. So what we're going to do is we're going to compute the Fibonacci numbers recursively. So what are the Fibonacci numbers? The Fibonacci numbers are just a sequence of numbers that are defined by what's called a recurrence relation. And what does that mean? That means that to compute some Fibonacci number, you do something with earlier numbers in the sequence. So here, to compute the nth Fibonacci number, you take the Fibonacci number right before it in the sequence and the number 2 back in the sequence and add those two things together. Obviously, you need the first two, or at least you need two numbers, consecutive numbers, to get this all started. So we're going to call that fib 0 and fib 1. And both of those we're going to have be equal to 1 in our example. That's the usual situation. So here's our Fibonacci sequence. We start out with 1, 1. Then to get this 2, we take 1 plus 1 is 2. To get this 3, 1 plus 2 is 3. Then to get the 5, 2 plus 3 equals 5. 3 plus 5 equals 8. So you get the idea. The nice thing about sequences that are determined by recurrence relations like this is that it's very easy to convert that to a recursive function. So in this case, you can see what that recursive function would look like. It's if n is equal to 0 or n is equal to 1, then return 1. That's just the base case to get us started. Otherwise, we have the recursive case, in which case we compute the preceding number and the number 2 back, add those together, and return that. As the next slide will show, this is not a good way to compute the Fibonacci numbers. So to illustrate how the Fibonacci numbers are computed, we're going to take the function that we just defined and pretend that it was called with the argument 5. And we're going to see how the fifth Fibonacci number gets computed using the function on the previous slide, the recursive function. So fib 5, obviously 5 is not equal to 0 or 1, so we'll go to the line in the program and see the recursive line in the program and see that we need to get fib 4 and fib 3. So first we need to get fib 4, so we will call fib 4 recursively, and then fib 4, again, 4 is not equal to 0 or 1, so it will go to the recursion part of the program, and it will need to get fib 3 and fib 2, so it will call fib 3 first, and it needs to get that value. So again, 3 is not equal to 0 or 1, so it will need to get fib 2. Fib 2 is not equal to 0 or 1, so it will need to get fib 1 and fib 0. Okay, so we're in fib 2. We need to get fib 1 and fib 0. We call fib 1. Fib 1 is 1 is equal to 1, so it will return 1. And then it calls fib 0. Fib 0 is also equal to 1, so it will return 1. And now fib 2 can take those two things that got returned to it, fib 1 and fib 0, add them together, and it will return 2. Now fib 3 now has fib 2, needs to get fib 1. Well, fib 1 will just return 1, and now fib 3 has both the things in its expression that it needs. It adds those together and returns a 3 to fib 4. Fib 4 now has one of the things in the expression it needs, namely fib 3, and it will now try to get fib 2. Fib 2 needs fib 1 and fib 0. Those are both 1. Fib 2 adds those two things together, gets 2. And fib 4 is now complete. It has both the values of each of the two calls that it needs. It can add those two things together and get 5. Now, fib 3 has one of the things it needs. Fib 5 has one of the things it needs. Remember, fib 5 needs fib 4 and fib 3. So it has fib 4. So now it calls fib 3. This is very familiar to what we've already done. Fib 3 will try to call fib 2. Fib 2 will call fib 1, which will return 1. Then it will call fib 0, which will return 1. Then fib 2 has both its things that it needs in its expression. It adds those together, gets a 2. Then fib 3 will call fib 1, which gets a 1. Fib 3 will add those two things together and return that. That gives you a 3. And then fib 5 can add the 5 and the 3 together, and it will return 8. Now, this, I want to point out and emphasize, this is not the way to compute the Fibonacci numbers. Why not? Well, take a look at this subtree over here, this part of the tree. Okay, for fib 3. Notice that exactly the same tree is over here. So there's a lot of redundancy. And as you try to compute later and later Fibonacci numbers, it gets worse and worse in terms of the redundancy in the program. And actually, the computational complexity of this grows exponentially. In other words, the number of instructions that need to be executed grow actually as roughly as 2 to the n, where n is the number of the Fibonacci number that you're trying to compute. So hopefully that was helpful. Good luck.